Hello everyone, welcome once again to Python with Opinkojo. Today we will be looking at tuples in Python. Some call it tuples. Well, tuples are very similar to lists with a major difference of immutability, meaning that when we create a tuple, we wouldn't be able to update the values or the object within our tuple. We'll get to understand that when we switch to Jupyter Notebooks. And in creating tuples, we make use of parentheses, and just as a list, we use commas to separate the various individual objects within our tuple. It also allows indexing and slicing, and then lastly, it allows different data types, just as in list. All right, so the first thing we'll be looking at is how to create a tuple. As I said earlier, we create a tuple using parentheses. So I'm just going to call this my tube, and then I open my parentheses, and I'm just going to pass in some values. And now if I check my tube, if I run that, I have my tuple. If I check the type of my tube and I run, it says it's a tuple. So what makes it a tuple is the parentheses. If I go ahead and change that to a square bracket, which we all know that is a list, if I run this now, it says a list. So that's the difference. We use parentheses and then we use the square brackets for list. Now I'm going to copy this, and this time I'm going to create a tuple with just one item in it, and let's see what happens. When I run this, it says an int. So there's an exception in tuple. We know that bringing the round bracket indicates that we are creating a tuple. However, when you pass in just one item, one value, Python sees that to be an int, because ideally the purpose of tuple is to hold multiple objects. So to be able to go around that, you can bring a comma after that, and now when you run, the type is now a tuple. That is just by the way, just keep that in mind. Now we're going to create another tuple that is a nested tuple. So what it means that a tuple within a tuple. Remember, I did see that tuple can hold different types of data types. So I'm just going to call this again my tuple. And then in this tuple, I'm just going to open that. I'm going to have my first item, second, and this time the third item is going to be a tuple of numbers. So 3, 4, 5. So what is happening here is that we have a bigger tuple, and in index position 0, we have 1, index position 1, we have 2, and then index position 2, we have a tuple containing under 3 items. If I go ahead and then run my tuple, we have that. If I run the length, if I check the length of my tuple, we realize that the length is 3. It is not 5, because the first is that, 2, and then 3. So that is the length of our tuple. So let's go ahead and then create another tuple with mixed data types. So I'm just going to use the same name, and I'm just going to call this. I open my parentheses and close. And then I'm just going to pass the information about the gentleman we've been encountering. So I'll just pass the name of someone. So I'm just going to say Kofi, and the wife is Ama. And let's say he is 87 years old, and his height is 6.5 meters. So this is a tuple that contains different data types. This is a string, that is a string, that is an integer, and that is a floating point value. Okay, now let's just jump down and see how we can access tuple elements. So after we've created tuple, how do we access the element in there? So I'm just going to create another tuple. I just call this tuple, and in this tuple, I'm just going to store some numbers, 9, and then let's say 10. Sorry for that. Right? Good. To access, just as in list, we can use indexing to access each element within the tuple. So I call my tuple name, that is the name of my variable, and then I open a square bracket. If I pass in the index 0, it's going to fetch the item at index position 0. So if I run that, you realize that we are getting 1. If I pass in -1, we all know that's going to fetch the very last item. If I run, we get that. Let's try the last one in this position 4. 0, 1, 2, 3, 4. So when we run that, we expect to get 5. We can also use slicing just as a list. So I can, if I want to say, let's say if I want to extract from 1 to 7, so it's going to be 1 in this, that's 0, 1, 2, 3, 4, 5, 6, 7. Remember, the last one is always exclusive. So we need to go one step ahead. So I'm just going to say index position 0 all the way to position 7. And when we run that, we're able to slice that. Remember, in slicing, we have steps. We can employ steps as well. We can go ahead and say step 2. And what it's going to do is that after every extraction, it's going to jump 2 steps. So let us run that and see. So you see, so we extract the first one. We jump 1, 2 step for 3, 1, 2 step for 5, 1, 2 step for 7. So that is how we can access elements within our list using indexing and then slicing. Now let us look at immutability of tuples. As we said, you can't update, you can't change the element within a tuple after you've created that. So to demonstrate that, I'm just going to create a list to compare the two, and in this list I'm going to store 1, 2, 3, 4, and I'm going to create a tuple. So tuple, and in this tuple I'm just going to store the same values, 1, 2, 3, 4. Good. Now, so let's go ahead and then try to change the first item in our list. We just do that. We call the name of the list square brackets. Then we specify the index position. Then we bring our equal sign. Let us update it from the integer 1 to a string 1. And when we go ahead and we check my list, now you realize that the first item has been updated. So this shows that lists are mutable. Let's go ahead and do the same update for our tuple. So we call tuple, and then at tuple index position 0, we are going to assign the value string 1. And that now when we run that, it ends up telling us that tuple object does not support item assignment. What it means is that once it's been created, we can't replace the values. So this shows that tuples are immutable. All right. Okay, so just to clear the issue of immutable, let me just go ahead and create another tuple. And in this tuple, I'm going to have 1, 2, 3, 4. And then at the last position, in this position, I'm going to have a list. I'm going to have a list of, let's say 6, 7, okay, 5, 6, 5, 6, 7. So if I go ahead and check that, I have a tuple. Now take note, the entire tuple is immutable, but remember lists are mutable. So what you need to understand is that each of the items in any of the index position of the tuple cannot be changed. So if I try, let me just prove that to you. If I try to do index position, let's say we want to replace this entire thing because it sits at index position -1 or index position 0, 1, 2, 3, 4. So let's just try to go ahead and then change that to, let's say, 10. If I run this, it is going to give me an error because we are trying to change an index position, a value at an index position within a tuple. However, we can change what is inside that depending on the data type that is being stored there. Here we are having a list in there. So we can use the same thing. So what we do is that we are using tuple. What we can do is that we can use tuple and then the index position to call out this entire list. And then we can go ahead and then select an item from that. So let's say I want to change what is at index position 5, index position 0, which is 5. I can just go ahead and enter 5. And now let me just make it obvious by updating with a string 5. And if I run now and I check my tuple, realize that there was no error. If I check my tuple now, realize that it's been updated. So note, we can't update any of the index position values at any of the index position within a tuple. However, if there is a data type within that tuple that has the property of mutability, then we can go ahead and extract those values within that data structure and change them.
All right, to further clarify this concept, let me just go ahead and copy this whole. So I'm just copying that. I'm creating a new tuple, and this I'm going to call it tup2. And instead of having a list in the tuple, I'm just duplicating the same thing. The only difference is that I'm updating this and making it a tuple within a tuple. So this was a list within a tuple, and this is a tuple within a tuple. Now let's take note of this. Since at index position 4 of this very tuple, we have a tuple in there, we can't alter. Remember, a tuple has the property of immutability. So what it means is that first and foremost, we wouldn't be able to change whatever is at index position 4. Let us try that. So 2, just as the first one, so at index position 4, and we are going to reassign the value, the string 5 in there. If I run this, we are going to get the same error. Why? Because we are trying to change this at the index position 4. So tuple is not going to allow us. Let's go further in, just as we did with the first one. So let's go ahead. After assessing this, we would want to go further into it and then change this 5 as we did with this one. So let's go ahead and call that 5 is at index position 0. So let's go ahead and then run that. And still, we end up getting the same error statement. Object does not support item assignment. This is the reason. The object at index position 5 happens to be a tuple. So at index position 4 happens to be a tuple. And because it has a property of immutability, even going further to alter a change to any of the objects within that inside tuple will still not allow you. If I change this to string now, string has the property of mutability. I can go ahead and do this, and I run this, and you see there is no error. If I go ahead and print tup2, it's been updated. Let us keep that in mind. Now, the last thing before we sign off for the day, we're just going to look at method. My full stop and then my tab key, and we realize that we are just having just 2 methods available. If we go ahead and check for this, you remember we had this. If we go ahead and check that, we realize that there are lots of methods available. So that is one bad side of tuple, just 2 methods available. So let's go ahead and then use the method count. And let's say I'm going to count the number of 5s that appears in this tuple. Let me clear this so that this will not be so obvious. Let me run this. Good. So we're going to count the number of 5s that appears in this tuple. Now, so I'm just going to pass the value 5, checking the number of times it is in the tuple. I run that and we get 0. Someone may be wondering why. Yeah, it's 0 because at index position 1, 0, we have 1, position 2, 1, 2, in that order. When we get to index position 4, we don't have 5. We rather have a list that contains 5. So at index position 4, what is there is not 5, but a list containing different integers. Now, let me just go ahead and update this and put 5 right here. And now, if I run this again now, I end up getting 1. So at index position 4 now, we have 5. If I go ahead and add another 5 somewhere here and I run, I'm now going to get 2. So there are 2 5s here. The question is, how then can we be able to count the number of 5s within the list in this tuple? So let's just go ahead and let me update this. Let me add some 5s. So to do that, first of all, note that we need to be able to access whatever is in this list. What is the position of this list? We know it's at the tail end, so we can use -1. So I can just call my square bracket -1. Sorry, -1. So we call our tuple, and then we call whatever is at this index position. Tube 2, index position 1, go ahead and count the number of 5s at index position 1. So if I run this now, we end up getting 4, because inside this list there are 4 5s. 1, 2, 3, 4. Well, that is all for tuples for now. Thanks for joining. Kindly subscribe, like, and then leave a comment. We would meet in the next session. Bye-bye.